Hi guys, welcome back. Today we're working on Unit 10, Section 2. This is Properties of Exponents and Logs. This is page 3. So here we have log base 5 of cube root of 5. The first thing I have to do here, I need to rewrite this cube root as an exponent. And I know the root or the index 3 right there is the denominator, and then the exponent of 5 right there, 5 to the power of 1, that's going to be your numerator. This is from a couple lessons ago. So from properties of logs, I know if I write this with the exponent right there, the exponent will move to the front, multiplying the whole log base 5 of 5. So, and that's exactly what I did there. So I rewrote the cube root of 5 into 5 raised to the power of 1/3. So that 1/3 will carry to the front, multiplying the whole log. Now, I know log base 5 of 5 equals 1. From the properties from yesterday, I have when the base and the argument are the same, that equals 1. That's where this one came from. And this 1/3 went to the front, multiplying. So now I have 1/3 times 1 equals 1/3. And then you ask, why can't I just put it in the calculator? Well, here is how you put it in the calculator. So you have math log base. So you can put log base 5 of 5 to the power of 1/3. That will give you 1/3 that you're looking for. And if you want to change that back to fraction, there's that. If you want, you can also put this in as a cube root of 5. So log base 5 of cube root of 5. That is also equals 1/3. Now, notice that here it says without using a calculator. If you didn't know this, what if you had the graphing calculator and you're like, I don't know how to do it, I'm just going to put it in. So what if you put that in like this with the exponent on the outside? You got 1. Well, the calculator is not wrong, but it's still applying the properties, but you just didn't put it in correctly. So when in doubt, just use what you know to come up with the right answer, because this is not what you're looking for. What you're looking for is the proper way, which that's the 1/3 that you had before. Okay? Now the second one, I have log base 16 of 2 equals what? The first thing I did here, I rewrote this in exponential form. So the base is always the base. So base 16 raised to the power of x equals 2, or equals the argument. So 2 to the power of 1. Now, if the bases are the same, the exponents are the same. The bases are not the same here yet, but I do know 16 equals 2 to the 4th power. So I rewrote 16 as 2 to the 4th power. And then this x is this x. Okay? So now the bases are the same. The exponents are also the same. So if the exponents are the same, I have for x equals 1. Therefore, x equals 1/4. So the next one is very similar to the first one we did. Where I have the argument right there with the exponent 8. Well, the exponent goes right there in the front multiplying, 8. Now, I have base 3, argument 3, that equals 1. So 1. All this equal 8. Okay? Log base 25 of 1/5 equals what? We're going to take this approach right here. So rewrite 25 to the power of x equals the argument. So 25 to the power of x equals the argument. Now, the bases are not the same, but I can easily rewrite 25 as base 5. So 5 squared is 25. This x is this x. Now, 1/5, I can also easily rewrite this as base 5. So 5 to the power of -1 equals 1/5. Now, the bases are the same, the exponents are the same. So 2x equals -1, x equals -1/2. Okay, natural log of e. Remember from yesterday, natural log is a log with base e. Of e is the argument. What is that? Well, from here and from here and from yesterday, when the base and the argument are the same, then that equals 1. Okay? Easy. This is very similar to this one. The difference is I have this exponent right there that will go in the front multiplying. So I have 2 that multiplies. I'm going to rewrite natural log of e as log base e of e. I know this equals 1, and I know this 2 will have to multiply 1. So 2 times 1 equals 2. Easy. Okay, 6 more. Now we need to expand. Expand means you have to make it bigger. So I'm going to apply the properties over here. So I'm dividing the arguments. So when you divide the arguments, you subtract the logs. So log base 3 of x minus, because you're dividing, log base 3 of y. That's all you're doing. Now the next one, you're going to have to do a whole bunch of things. We're going to go a couple steps here. So here I see you're multiplying x squared times y cubed and also dividing by z squared. So I'm going to do that first. So log base 10, or common log, of x squared plus log of y cubed minus, because we're dividing, log z squared. Okay, now I need to deal with the exponents, and the exponents will all go in the front multiplying. So 2 log of x plus 3 log of y minus 2 log of z. There's nothing else we need to do to simplify. That's fully expanded right there. Now, this one, I see 2 things. I see natural log of e squared, and these parentheses right here indicate that e squared is multiplying x minus 2. And that's exactly how I'm going to approach this. So natural log of e squared plus, because I was multiplying, natural log of x minus 2. Now I also need to deal with this exponent right there, goes in the front, multiplying. So 2 natural log of e plus natural log of x minus 2. I can simplify one more thing, because I know natural log of e is the same thing as 1, because we just did that right here. So 2 times 1 is 2 plus natural log of x minus 2. And that's all you can do here. You cannot split that up because this is the argument. All right. Here we have x to the 5th power divided by x squared minus 1. So we're going to split that up, considering this is a division. So I need to put a subtraction right there. So log base 2 of x to the 5th power minus log base 2 of x squared minus 1. What else can I do here? Oh, I need to do this, where the exponent goes in the front multiplying. So 5 times log base 2 of x minus log base 2 of x minus x squared minus 1. And that's it for that one. So the next one, I see multiplication right there between x and square root of x plus 3. And I also see division here right there at x plus 4 cubed. Let's go that route first. So log base 3 of x plus, because I'm multiplying here, log base 3 of square root of x plus 3 minus log base 3 of x plus 4 cubed. Okay, let's go ahead and rewrite this as exponent 1/3. So log base 3 of x plus log base 3 of x plus 3 to the power of 1/3 minus, this will go in the front multiplying, 3 log base 3 of x plus 4. I'm going to deal with this exponent right there, and that's going to be the last step. So log base 3 of x plus 1/3 log base 3 of x plus 3 minus 3 log base 3 of x plus 4. Can I simplify anything else? No, I can't. Last one. You're like, yeah, right. So this is not as bad as it looks, but let's think outside the box here. So I need to find log base 5 of 1 over 250. Okay, so I see, oh, that equals what? I really want to rewrite this in exponential form. So 5 to the power of x equals the argument. So 5 to the power of x equals 1 over 250. Now, I'm gonna go, but this doesn't help me. I can't just do that. So I'm gonna do log base 5 of 1 over, if I do 2 times 125, that gives me 250. So 2 times 125, that gives me 250. So, and then I can split up these two fractions. I can make log base 5 of 1/2 times 1 over 125, because this way right here just didn't work out for me. So now, since I'm multiplying here, I can just add them. So log base 5 of 1/2 plus log base 5 of 1 over 125. Okay, so this, I can't do anything to simplify that, but I'm going to do this math right here off to the side. So I have log base 5 of 1 over 125 equals what? Well, I can do 5 to the power of x equals 1 over 125. So 5 to the power of x equals 1 over 125. Well, I can rewrite this 1 over 125 as 5 to the power of -3. You're like, how do I know that? Well, you need to, 5 cubed is 125. And negative exponent makes the inverse. That's the reciprocal. Okay? So here I have that this whole thing equals -3. Okay? So I have finally log base 5 of 1 over 2. This equals -3. So -3. And that's all I can do to simplify this one. The end. I will make another video for page 4.